Hello, everyone. Welcome to our class today. Our topic today is the inference based on a single sample with confidence intervals. Let's think about this question here. Suppose a large library needs to estimate the average length of time that people remain in the library. So the library's target parameter is the population mean. To achieve this objective, the library administrators plan to randomly sample 100 of all previous records and to use the sample mean of the length of stay to estimate the mean of all people's visits. So as we have learned before, the sample mean can be used to represent the point estimator of the population mean. But how can we assess the accuracy of these large sample point estimators? So with this question, let's begin today's class. First, I want to let you know that what knowledge you need to prepare for today's class. So you first need to know the basic concept of sampling distribution, including but not limited to its formation process and its properties. And the second is the sample distribution of mean and proportion and the process of generating point estimators. I believe that all of you have known the generating process and the formula here. And the third one is the calculation about normal distributions. So if you have known all of this knowledge, let's see what you are expected to get in today's class. So first, I want you can have an idea of the definition and property of interval estimators. And then we will learn the process of generating confidence interval about population mean and proportion. And the last is I want you can apply what we have learned today to solving some real world inference problems in mathematics or other areas. So now let's begin with the first part, the definition of interval estimator. So we have already learned the definition of the point estimators, and the interval estimator here is the method that uses the sample data to generate an interval that estimates the target population parameters, such like mean and proportion. So this interval contains a range of values within which the true parameter is believed to lie, along with a certain level of confidence. So this interval is also called confidence interval. So we can see from the below graph that like X bar is what we learned before. It is the point estimator that we use X bar as an estimation of the population mean mu. But now we will extend this point into an interval. You can see that it has the like margin of area in its right and left-hand side. So in this topic, we'll need to solve like what is this margin of area and how the interval is look like. So now let's come to the second part, the property of the confidence interval. So first, the midpoint of this confidence interval is determined by the point estimators, and its range is partly determined by the confidence coefficient, which is the probability that the interval encloses the population parameters, no matter it is the mean or the proportion. So in the questions we made, we always express the confidence coefficient as the confidence level, which is in percentage terms. For example, if our confidence level is 95%, then in the long run, it means that 95% of our sample confidence intervals will contain our target parameter, that is mu. So from this confidence level, we can get the alpha, that what we need to in our calculation is equal to 1 minus 95%, that is 0.05. So alpha by 2 is 0.025. So we can see this in the below graph. Like this is the symmetric line, and the alpha in this graph, it represents the area in the lower and the upper tail. So because the graph is symmetric, so the area here in the lower tail and the area here in the upper tail are the same. That is alpha by 2. So as we have learned in our normal distribution, we can use this area, that is the probability, to get the z value here. So it seems like a critical value here. And in this table, I also show you that some common confidence level that we will meet in our future questions. And you can remember these values that you can use it directly in your future solving problems. Like if the confidence level is 90%, then its corresponding z value is 1.645. It is very convenient for you to use it directly. Then let's come to the part 3, the process of generating confidence interval. So for the confidence intervals generating process, I divide it into 2 main categories. The first one is to calculate the interval for the mean, and the second is to calculate the interval for the proportion. But for each category, we can divide it into some small parts. Like for the mean, we will learn 2 kinds. That is for large sample and for small sample. But for proportion, I will just learn the large sample here in this class. So first, we can say how to calculate the confidence interval for the population mean in large sample. So first, we need to look at the required conditions for the formula up below. So the first is a very basic condition here, that the random sample we use is selected from the target population. It is very necessary and important. And the second one is that the size of sample N is large enough, as we call it a large sample. So how do I know if it is large enough or not? We have a formula here that if the N is greater than 30, then we can think the N is large enough. So why we have this requirement? Because due to the central limits theorem, this condition guarantees that the sample distribution of X bar is approximately a normal distribution. And also for large N, that the sample standard deviation S will be a good estimator of the population's standard deviation sigma. Because we have 2 kinds of situation here, the first one is that we know the population standard deviation, so we can directly use it and go to the z table to find our corresponding z value. But for the second situation, if we do not know the population standard deviation, if the size of sample is large enough, we can use the sample standard deviation S to represent the population standard deviation sigma. So both 2 situations, we can go to the z table to find the z values. But for the second category, the small sample, so first look at the conditions. The first is necessary that the random sample is selected from the target population. But the second one is more simple, that the population's relative frequency distribution is approximately normal. So we also have 4 kinds of formula here. The first one is that the population standard deviation is unknown, because the sample is not large enough, so we cannot use the S to represent sigma directly. So in this part, I need to go to the t table to find the corresponding t values and put it into our formula. And for the second situation, if the sigma is known, so we can directly use the t values. It is the same with the previous part, the large sample. So for the last category, it is a large sample for p hat. So the required condition, the first one is all of the same, that the random sample is selected from the target population. And the second one is the size of the sample N is large enough. But for this situation, we have 2 formulas to check if the N is large enough. The first one is N multiplied by p hat is greater and or equal to 15. And the second is similar, like multiplied by 1 minus p hat is greater or equal than 15. If it meets these two requirements, we can say that the n is large enough. And for this, we also have a formula here. So after we know the whole generating process and formulas for the confidence interval, we can apply it to some real world questions. So for the first questions, let's see. So the unoccupied seats in flights cause airlines to lose revenue. Suppose a large airline wants to estimate its average number of unoccupied seats per flight over the past year. To achieve this, the records of 225 flights are randomly selected, and the number of unoccupied seats is noted for each of the sample flights. So the data is given below, and the question is to estimate the mean number of unoccupied seats per flight during the past year, and the given confidence interval is 90%. So as the data are all offered to you, you can just put it into our formula, and the only thing you need to do is to find out the z-value. Because the confidence level is 90%, so we can know that the alpha is 0.1, and you can also know that the alpha by 2 is 0.05, and to find the corresponding z-value is 1.645. So put all the data in our formula, then you can get the 90% confidence level that estimating the mean number of unoccupied seats per flight is between 11.15 and 12.05. So for question 2, it is very similar. But in this question, you can see that in this table, I gave you the samples data. So the first step for you is you need to calculate the samples mean and sample standard deviation by yourself. As the sample size is only 6, so it cannot meet the requirements of large sample. So it is only the small sample. We need to convert our formula into the small samples formula. So we can see that you need to go to the t-table and find the t-value. Then you can put the data you have calculated into this formula. And the question 3 is about the proportion. Like suppose the samples contains 484 consumers, and the find that only 157 consumers are optimistic about the state of the economy. So with a 90% confidence interval, we need to find out that the minority of Florida consumers is optimistic about the economy. So firstly, we need to use the data from the sample to calculate the p-hat. Then we can use the p-hat into our formula to calculate the confidence interval based on this 90% confidence level. So all of these 3 questions are about how to use our calculation of confidence interval into some real world problems. And we can also see that the confidence interval have more important and more deeper application in the areas besides mathematics, like finance or like economics. So here this is some of the examples that we can use the confidence interval in finance and economy. So now let's come to the last part, conclusion. So remember what we have learned today. First, we learned the definition and properties of confidence interval. Then we know how to calculate the confidence interval using different kinds of formulas. And then we come to the application in mathematics or other areas of the confidence interval. So as we have learned 2 kinds of estimation, like the point estimation and the interval estimation. So what can interval estimation behave better than points? Interval estimators can offer a more comprehensive and informative approach to estimation by incorporating measures of precision and uncertainty. So this property makes the interval estimator can behave better. So that's all for today's class. So do you have any question?